Hi everyone. So in this video, let us start discussing about a model for network security. Now, if you ask me what is this model for network security, we have studied about the security attacks, security services, and security mechanisms. What are they? How many different types are there? What are the core objectives of security? All those kind of things. Now, to put it into a practical perspective, where do we actually implement them and how do we implement them? Now, for that, there is one generalized model which has been given for network security, where let us assuming that there are two parties who wish to communicate across the internet and send the information over. How do they do that with security incorporated into their transmission? Now, let's see what it is. Let us hoping that generally speaking, let us assume that data is to be transmitted over the internet between two communicating parties, which we call them as principals, and who must cooperate for the exchange to take place. In simple sense, let us say that we have a party A and we have a party B. If they both want to communicate with one another, first there must be some kind of path that is selected for the transmission to take place from A to B. That is what we call as a logical information channel. Usually it goes through the internet, which might consist of many networks, many devices, intermediary devices, and it can be of anything, literally. So a logical information channel is established by defining a route through the internet from source to destination by use of communication protocols by the two principals. If you remember, we have the OSI model and the TCP/IP model, all the hierarchy of the layers. So if A wants to communicate with B, the communication has to be taken place through with the use of protocols at each layer, and then finally the physical layer sending the information in the form of signals across the channel. Same thing happens if encapsulation takes place at A, reverse process called as decapsulation takes place at B, and finally the data is delivered to the user, isn't it? Now, this is quite simple. If A wants to be, we have studied a lot of this, how communication takes place, how different protocols are coming together to make this happen in computer networks. But coming to security part, here, if you want to incorporate the security aspects, maybe if you want to safeguard your data against attackers, or maybe if you want to ensure that data is not modified by an authorized party, there we have to see to that how the security aspects or security concepts can be integrated to make this communication secure. So security aspects are needed when the data that is to be transmitted needs to be protected against opponents who may present a threat to confidentiality, integrity, and other security services. For this, there are two most important actions that need to be taken care of. The two core components that are present in almost all the security providing techniques are, the first one is a security related transformation. So what is the security related transformation? In the mechanisms we studied about encipherment and also data integrity mechanisms, isn't it? So here what you are trying to do is, when you have something to send, or when A has a particular message that it wants to send across to B through the internet, it will not simply send it straightforward. What it does is it puts, or it makes use of an algorithm which converts this message into an encrypted format. That is a format which might not be able, or which might not be understood by a third party which is sitting across the network. And this message could only be read by its intended recipient, which is B. So if I want to send a message to my friend, I want to ensure that this message could only be read and understood by my friend itself. Nobody else sitting in the middle, nobody else on the internet should be able to read it. Even though they read it, they should not be able to understand what the message is. So the security related transformation on the information to be sent, making it unreadable by the opponent, this is one part, which ensures confidentiality, and the addition of a code based on the contents of the message used to verify the identity of the sender. This ensures the authenticity of the sender. So because A not only should be assured that this message is not read by anyone, and also B should be assured that this message in fact came from A. That is where this addition of a code, you can see it is of two parts. The first part tells you that you add or you do some kind of transformation so that an attacker is not able to understand what you are sending. Similarly, the second part tells you that you add some kind of code so that the receiver will be assured about the identity of the sender. Now, what is the second core component? The second core component is it talks about a key, or here we call it as some secret information, but in general, we speak about a key in network security. Some secret information shared by the two principals, and let's hope it is not known to the attacker. The entire security thing is based on how well you can keep the key secure, how well you can secretly share the key between the two parties, and hopefully to the opponent, unknown to the opponent. A trusted third party may be needed to distribute the secret information or to arbitrate disputes related to the authenticity of the message between the principals. Now, let me show you how this all fits together. Okay. Now, this is what. See, this is my sender. This is what I've been telling. Let it be my A and let this be my B. This is my sender. This is my receiver. So A wants to send a message to B, isn't it? No. As I told you, any security implementation does have two core components. The first component is what kind of transformations that we are going to perform on the message. You can see this is the message that A wants to send. This is given as an input to this particular round color thing, which we call it as an algorithm or security algorithm. This is my security algorithm, which accepts this message as an input along with the secret key. Both of them are put into this algorithm, which generates a secure message. Also, in other terms, we call it as a ciphertext. We call this as a ciphertext on this message. This is given as an input, and this ciphertext is the one which is actually transmitted across the internet through the information channel and which is received by your recipient. Hope you are getting me. So here A, which is my sender, first selects the message which it wants to send, and this message is given as an input to the security algorithm, which also accept a secret key as an input and then generates something called as a ciphertext, which is now transmitted across the information channel and which is the one which actually the recipient gets. In order to read this message, the recipient has to do an inverse transformation, which we call it as decryption. This decryption algorithm accepts this ciphertext as an input and the same secret key which is used here as the second input. So the decryption algorithm accepting the ciphertext and your secret key as inputs will now recover the original message. So this is how a security concepts are implemented. Because this is now encrypted, even though the opponents are there while the message is being transmitted, even though they can see what is here, they will not be understand what this message is actually about. Because once you perform this mathematical transformation or security related transformations on the original message, this will be into something called what we call as an unintelligible form. That means which we will not be able to understand anything. Okay. So this unintelligible format could not be understood by the opponent. Now for this to be understood by your recipient, whatever transformation I did here, it has to be reversed so that he will be able to reproduce or recover the original message back. Now, for this model to work, and also please do not forget about the trusted third party, the role played by this trusted third party. Usually, the main role played by this trusted third party, which we call them as an arbitrator or even the certificate authority in some cases, is to secretly share this particular key, is to secretly share this secret key among the two parties to ensure the authenticity of this key. And in case if there are any disputes that has arisen between these two parties, it is up to the trusted third party to take care of those disputes or to settle the disputes between these two parties. Now, this generalized model consists of 4 important tasks. The first task is design of an algorithm. So what is this algorithm is all about? So design an algorithm for performing the security related transformation. The algorithm should be such that an opponent cannot defeat its purpose. So what is the purpose of this algorithm? To convert your original message into something which cannot be understood by your opponent. But basically, if an opponent can get a good look at this, and if he is able to guess what the key is or guess what the message is, then what is the purpose of this algorithm? It is practically useless, isn't it? So that should not happen. So you design an algorithm for performing the security led transformation, and it should be strong enough such that it has to serve its purpose. It should be able to beat the opponent's attacks on the algorithm. Second most important task is to generate the secret information to be used along with the algorithm. As I told you, the algorithm not just accept your message as an input, but it also will take a secret key which is known only to the sender and the receiver only, isn't it? So how do you generate the secret key information? If there is a means through which both A and B can generate it independently, or they might seek out the help of a trusted third party to distribute the keys, whichever way. But there should be some prescribed way to generate the secret information that is to be used along with this information. The third one is develop methods for the distribution and sharing of the secret information. Of course, you generate the secret information through which way you can communicate this secret information with that of your receiver, with that of the recipient. You have to do it securely, because if an opponent generally knows what this is, usually all the security algorithms are standardized and well known to the public. They are publicly available in the internet. You take AES or take DES or take RSA, everybody knows how it works. So even the opponent or the attacker has got good information on what the algorithm does. So if you do not maintain the secrecy of this information, or if this information is not maintained properly or not shared securely, then the whole diagram what you're looking at, or the whole model, is utterly useless. So that is the third important task. The first task is design of an algorithm which is strong enough. The second task is how do you generate the secret key. The third task is how do you secretly distribute this information among your receivers. The fourth one is you have to specify a protocol to be used by the two principals that makes use of the security algorithm and the secret information to achieve a particular security service. What this actually means is, as I said, it has to be there. It has to be in some kind of standardized manner, isn't it? So you have to design a protocol which will say that, okay, you use this algorithm with this particular key, and then you send the ciphertext in this particular manner. So here you have to specify a protocol which is standardized in a manner both the sender and receiver will be doing this security related transformation according to this protocol itself for successfully implementing the security services or the security related concepts for their information transfer. So this is only one side of the spectrum where I'm talking about how do you implement the security for communication that's happening between two parties. Also, on the other side of the spectrum, we have another issue. What is that? Is your organization might have a very valuable information or sensitive information. Imagine you are having a bank. In the bank, all your account details, your personal information, your other social security details, everything is stored within the bank. If I'm an attacker, I will be more interested in trying to penetrate your security and acquire the information from the bank, or I will try to find a way to enter into that particular information system, to compromise that system and steal that information. So various other threats to information system like unwanted access still exist. The existence of hackers attempting to penetrate the systems accessible over a network remains a concern. So in the earlier model, we were actually talking about the providing of security between two communicating parties. Here I'm trying to implement some kind of security concepts for safeguarding my own information system. Of course, it has to be readily accessible via the internet, but making it readily accessible also makes it vulnerable to outside threats, isn't it? And also inside threats as well. Another threat is placement of some logic in computer system affecting various applications and utility programs. Nowadays, you get a lot of spam emails and a lot of, you can see you might getting different messages with various links to click on to spyware, adware, malware, a lot of names are given. This is a big issue where unknown to even the user, these kind of malware might be resident on your system and make it ineffective, or might make it function in a completely different manner to what it used to be. So all these things has to be taken into consideration. The best thing what we do is, you can see viruses and worms are two types of software attacks that are inserted into the system by means of a disk or also across the network. So if I'm an attacker, I might send you a link saying that, hey, open this and get a maybe a free dinner on your birthday. Everybody gets interested for free goodies. So if you click on the link, unknowing to you, in the background, it might download some kind of malware onto the system. Now, once the malware is onto the system, it might transfer control to the attacker. It makes your system vulnerable. And if you connect your system to your organization's network, automatically the attacker now has a gateway to enter the corporation or the organization's network via the user system. You can see this. Information access threats intercept or modify data on behalf of users who should not have access to that data. Similarly, service threats exploit service flaws in computers to inhibit use by legitimate users. There are two ways to look at it. Maybe a hacker can masquerade something. He can send you an email attachment, or he might give you a free pen drive as a gift, which might contain malware. Without any knowledge of it, you might plug it into one of your systems, which automatically infects the entire network. He might be after the information that is stored on your computers, or he might want your computers to just crash and your organization to fail. Anyway, he can do anything he wants. So how do you safeguard from such kind of threats? The earlier model told you that described about how you can safeguard your information while transmitting, or how both the communicating parties can come to an understanding and keep the information safe from attackers who are there on the internet. But how do you safeguard an information system? Your own information or your own data, process, software, your sensitive information, all those kind of things. For that, what we have is, there is, once again, these threats can be countered through two ways. The two different ways are, the first one is placing a gatekeeper function, which includes a password-based login methods that provide access to only authorized users, and also a screening logic to detect and reject worms, viruses, etc. So you can keep a kind of firewall or a gatekeeper function just before your information system. So anybody who is trying to access this information system has to go through this particular gatekeeper function first. What it does, it actually tries to authenticate each and every request that is made for accessing this particular information system. It might look for a password or a PIN number or something else. And even you can also place a screening logic so that any packets that are entering into your network or that is going out of your network can be screened, and you will be able to detect maybe the presence of malware such as your viruses, worms, trojans, etc. and etc. So this is one way to ensure that outsiders might not get easy access into your information system. Thereby, you can stop them by properly implementing authentication procedures and also properly implementing a screening logic, so that anything which is trying to enter your information system is screened first. The second way is, in case if you have a disgruntled employee. What do you mean by disgruntled employee? He is an employee of your organization, but he is not happy with your organization. He can simply bypass this, isn't it? Because he has the necessary credentials to enter the information system. This can protect you if the attacker is coming from outside, and if he is doing some kind of this malware, trying to implement some kind of malware, or trying to sneak some kind of malware from through an USB device or something like that. But what if you are an authorized user of the organization? How do you stop him? You cannot stop him at the gate because he has got all the credentials to enter into the system. For that reason, usually for every information system, what we do is we employ some kind of internal security controls and policies. what it does is this will keep on monitoring the type of access that a particular individual is doing to the information system. It will log everything up. It will ensure that if a person is trying to access something that he shouldn't, maybe checking his behavior patterns, if it is any abnormal behavior, if he is downloading something which he should not have access to, downloading onto a disk or making an attachment, any such action has to be monitored and immediately reported to the security center, maybe security manager or security engineer, whoever is present on site. So an internal control monitoring the internal system activities, analyze the stored information and detects the presence of unauthorized users or intruders. So we are simply presenting a second line of defense for your information system. The front line defense is placement of a gatekeeper function, which will implement strict controls like authentication controls, maybe to screen who is trying to enter in, and also if there are any kind of malwares or anything who is trying to push it into your information system. The second line of defense in such a case is to make use of these internal security controls and policies, which keeps on monitoring what is happening within the system, which user is accessing what kind of resource, and if he is doing it within his norms or not, within the constraints that you placed for that particular user or not, or if he's deviating from his normal behavior and trying to access which he shouldn't. All those things comes into play. So the these are the two ways through which you can implement security concepts so that you can safeguard your information while you are transmitting from A to B, or even while the information is placed onto a particular information system, and it can be accessed remotely through network. So with that, I hope you understood how these models comes into play. And basically cryptography and network security subject is to explain each and every one of these, where the algorithms, how or the different algorithms that we use for ensuring confidentiality, and later on we go through the different types of firewalls, different types of web security approaches, SSL, TLS, and even IP security approaches, VPNs. All those things will be covered as part of this. So it is vital for you to understand why we need to do all these things. These are the threats, and this is how we can counterattack the security threats coming from an intruder or from an attacker or even from an insider threat as well. So let us see how we can do this in the next video. So till then, take care and good luck. Thank you.